Hello. Today we're going to take some notes on ratio diagrams, and they're going to go on page 61 and 62. We will start on page 62. That's where your notes page is going to go. On 61, you will see that is where our practice page is going to go. So make sure you get those two pages in place, and then we're ready to begin. On page 62, you'll notice that our topic is ratio diagrams. Our essential question is, what are some other ways to represent equivalent ratios? We are doing standard 6 RP3, ratios and proportions again. And by the end of by the end of this lesson, you should be able to solve rate. Remember, rate is when we have two ratios with different units, or a ratio with different units, problems using tape diagrams, the model version of a model that we use, and double number lines. Okay. So once you get that down, let's go down to our first example. And this example is using a double number line. You see that there are just two simple number lines that were created, and one represents one part of the ratio and the other represents the other parts of the ratio. Let's read our story problem. Sam bikes 20 miles in 1 hour. If he continues at this rate, how far will he go in 4 hours? Let's first start off with circling 20 miles, 1 hour. How far will he go in 4 hours? Okay, so we know that our first is 20 miles. That's our first ratio. It's our rate. 1 hour. Right? And we want to know 4 hours, how many miles? Okay, so what we did here is on these two number lines that we have, we first start off by labeling them. And we labeled the first one miles, because you'll notice we have miles in a ratio. And then the second one is hours, because we have hours in a ratio. So each number line represents a part of the rate or ratio. Now we're going to count by 20 because that's our first, it's the unit rate. So we start off with our unit rate, and we see that 20 miles is how far he can go in 1 hour. So continuing along with that, we would actually just continue numbering the number line, and we're going to count by 20s. So 20, 40. So if you can do in 1 hour 20 miles, in 2 hours it's going to be doubled. You can do 40. And then we have 60. So we're just going to continue this pattern. 20, 40, 60, 80, 100. And then with the bottom, we're just counting up. So 1 hour, 2 hour, 3 hours, 4 hours, and 5 hours. So now we're going to solve our problem. So we're trying to figure out 4 hours. So if we use our number line, we're going to count 1, 2, 3, 4. So if you notice, our number lines are perfectly lined up. If we box here, we know that in 4 hours, he could do 80 miles. So Sam could bike 80 miles in 4 hours. And I bet he would be awfully tired. Okay, so that is a double number line. So basically you set up two number lines using each unit from the ratio. You number them so that they're evenly spaced, and then you find the unit rate. Once you have the unit rate, then you just continue in the pattern of the unit rate until you get to the part of the information that is given, and then you connect it to the other number line side, and that will be the information that's missing. Okay, let's now look at this tape diagram. Okay, so in this tape diagram, Sam bikes 30 miles in 2 hours. With that being the case, how many miles can he bike in 5 hours? Okay, so the first thing we're going to do is we have these little tape diagrams, and these represent an hour each, okay? And we know that in the first 2 hours, Sam can do 30 miles. Now, I'm going to come down here and I'm going to write some information. I know he does 30 miles for 2 hours. But I also know that on my tape diagram, 30 miles represents for 2 blocks. Okay? If that's the case, if 30 miles is for 2 blocks, 2 even blocks, we know then that each block is how much? If 2 blocks is 30, could we then divide 30 by 2 to figure out what each block represents? And if we did that, 30 divided by 2 is 15. So then we go back to our tape diagram and we put in this represents 15, this represents 15, because we know that we have 2 blocks, 2 hours, 30 miles. So each one has to represent, he did 15 in each one. So now that we know that, we can evenly draw the same box sizes, and we can put that each of these, there are 5, so we drew 5 boxes, and knowing that each of these pieces represents 15 minutes, we can fill that in the boxes. Okay, so now we know each of these 5 pieces represents 15. So let's now multiply that. We have 15, 1, 2, 3, 4, 5. 5 times, we're going to get 75. So this chunk equals 75 miles. Recall that each of these represents 1 hour. So 5 hours, he can do 75 miles. So once again on this one, you draw 2 boxes. Those boxes represent the 2 hours. You know that in those 2 hours, he can go 30 miles, so you divide it in 2, and that represents each box. Once you did that, then you did another diagram to represent the 5 hours we want to find. Knowing that each of these represents 15 minutes, we keep spreading them out until we get to the 5 hours that we're counting, and then we add those up and we get the total for the 5 hours. Pause here if you need to go back. Now, let's take a moment. We're going to shift over to page 61. All right, on page 61, we have 2 more examples. We have one with a tape diagram and one with a number line. So we're going to start with the double number line. We always begin by marking our text. I need 2 pieces of blue fabric for every 5 pieces of red fabric for a quilt. How many blue will I need for 20? So 2 blue fabric, 5 red fabric. How many will I need for 20 red? Okay, so let's start off by looking at what is our beginning ratio. We did a number line for blue. We did a number line for red. We have that the original was 2/5, and we got that up here, 2/5. We're going to be going to 20 pieces of red. Okay, so to do that, we're going to go to our red fabric and we're going to keep counting by 5s until we get to 20. And actually, I might even go a little bit farther. So 10, 15, 20, 25. Okay, so I've now numbered my red. And knowing that we have 2/5, 2 pieces of blue, 5 pieces of red, we want to get to 20 red. We don't know the blue. So we're going to think about this. If 2 pieces of blue is good for 5 red, what then would 10 red be? Well, if I look at this relationship, it looks like it was doubled. Okay, so that means here I'm going to double and I'm going to be putting 4. Well, it looks like now these are evenly spaced. I'm going to be counting by 2s. 2, 4, 6, 8, 10. Okay, so now I have my number lines lined up. So we need to go to where there's 20 red, which is right here. Circle it. So now I know if I have 20 red, how many blue do I have? 8. So we know I need I need 8 pieces of red for 20 blue. But let's check this, okay? 2 blue, we don't know how many blue. 5 red, 20 red. Okay. So with that, how many times does 5 go into 20? 4 times. 4 times 2 is 8. So it does add up. We can use this number line to help us solve it. Let's look at the next one, the tape diagram. I need 2 cups of grape juice for every 3 cups of apple juice for the punch I'm making. If I have 12 cups of apple juice, how much grape juice will I need? Okay, so let's now look at our tape diagram. All right, we're going to start off here. This is going to represent our grape juice. This is going to represent our apple juice. Okay, now I know that I have 2 cups of grape for every 3 cups of apple. So I have 2 to 3 equals, it says 12 cups. So we're going to do, we have 12. So this is apple, this is grape, this is grape, we don't know it, this is apple. So this is the proportion we're trying to solve. Okay, now I have 2 cups of grape, but I don't know how much is in each cup. And then I have 3 cups of, I'm sorry, 2 portions of grape to 3 portions of apple. And that's based upon my first initial. Now, in this 3 portions of my second ratio, I know that these 3 portions represent 12. So if I have 3 different spots and it's worth 12, couldn't I divide 12 by 3 and find out the value of each of these 3 spots? Well, 12 divided by 3 is 4. So I can put in that each of these spots represents 4. 4, 4, 4. So if that's what a portion of the tape represents, now I can go up here and fill in here too that each of these represents 4. So now my 2 pieces represent 4 each. Well, if I add them up, 4 plus 4 equals 8, meaning that if I have 12 cups of apple, I have 8 cups of grape. So I need 8 cups of grape juice for 12 cups of apple. So let's see now that if that worked. 2 to, 3 to 12. What do I do to 3 to get to 12? Well, I multiply it times 4. 3 times 4 is 12. 2 times 4 is 8. That is true. So remember, when you're doing this, you just look at the initial ratio, draw your tape diagram equivalently, figure out the one that you know, divide it by the amount of strips that you have. That tells you the value of each strip, and then fill in the top part of the ratio, and then add it up. So these are just 2 other ways for you to be able to solve ratio problems using models. We already learned how to use an ordered pair. We learned how to use a table, and now you have a double number line and a tape diagram. Have a great day.